Dear students, welcome to the video lecture of dynamic memory allocation. Actually, dynamic memory allocation is a technique in which a program can allocate a storage space in the memory. It's a method the space for the program is allocated from the free space during the execution of the program. Okay, the memory is allocated during the execution of the program, that is known as a dynamic memory allocation. The free memory is called heap. So this is a memory. It contains a segment for the local variable, and we have a free memory that is called heap. Okay, from the heap only memory will be dynamically allocated uh, when you perform dynamic memory allocation on the space for the global variable and program instruction and static variable. The storage is known as a permanent storage area. Free memory is a heap storage. Local variable is known as a stack storage. Is known as a stack storage. From the free memory, we are allocating a memory during a runtime is known as dynamic memory allocation. For example, the advantage of dynamic memory allocation is if you're declaring an array of size 100 is an integer array, what will happen? Then 400 bytes will be reserved, but your array will only take 20. It's only 20 values means remaining 80 into for 320 bytes will be a waste. So avoiding this such a kind of waste, what we are doing, we are allocating memory dynamically. So static declaration, it consume more memory. They are not fully utilized. That's why the dynamic memory allocation is a very optimum choice. We can allocate the memory and as well as we can release the memory at the runtime. That is known as a dynamic memory allocation. Memory allocation functions. This function is used to allocate the memory space in bytes to a variable of different data types. The function reserves bytes of a determined size and return the base address to the pointer variable. Allocate the memory. Allocate memory is again the base address is returned that is stored in a pointer variable. So pointer variable is mandatory. So the prototype are declared in sort of a dynamic memory allocation. The prototypes are declared in alloc.h, stdlib.h. You have to include the header file alloc.h and stdlib.h. Okay. Then first we are going to discuss about the memory allocation function malloc. Malloc function syntax. This is ptr is a pointer variable. Open and close parenthesis. Data type now to followed by a star. Then give a malloc and within a open close parenthesis followed by open close parenthesis you have to give a byte in size. PTR is the point data type. Malloc function returns a pointer to area of memory which is size of byte size of the byte size. Allocate the memory on the actual base address is the return base address is stored in the pointer variable PTR. If the space is insufficient, allocation fails, returns the null pointer. If space is insufficient, allocation fails and returns the null pointer. Example, okay, we are giving an example here. Integer star is a data type. Okay, this memory space is going to store the integer values malloc into 20. So 20 bytes of the memory is reserved in the consecutive memory location. 20 bytes is allocated. The address of the base address, I mean the element of the first element address, zeroth position is returned to the base address is returned. It is stored in the pointer variable pnt. Okay, so 20 bytes are allocated to a pointer variable pnt of type integer, and base address is written to the pointer variable to the pointer. Okay, base address is written to the pointer. Then there's an example program. Let us see program to demonstrate the malloc in dynamic memory allocation. We are having a three function malloc, calloc, calloc, and realloc and free. We are going to discuss one by one. So malloc, okay, malloc. The first example is malloc. Okay, the example I'm declaring integer variable k. I'm including stdio.h, stdlib.h. You can include that sufficient. Okay, I'm declaring integer variable k and a integer pointer star p. I initialize and an integer variable j. I initialize it to 0. I asked the user enter how many numbers. Okay, he want to store. I capture the value in the variable k. Scan of percentage d ampersand k. So p equal to integer star. Okay, this is the data type. Malloc is a function. K is a number of element. How many number of elements that the user want to store? Okay, all are integer element into size of integer. Okay, size of integer 4 bytes means okay. The user want to store 5 numbers. Okay, total 20 bytes will be written. User wants to store 10 numbers. 40 bytes will be written. The base address is stored in the pointer variable p. Okay, while j is not equal to k. Okay, actually j's initial value is 0. J is not equal to k. I print of number equal to percentage d plus j plus 1. It will display number 1. Okay, j's value initial is 0. So when user enter the number, what will happen? Scan of percentage d comma p comma j. So j is 0. The base address, the number first number will be stored. J will be incremented. Then check j is not equal to k. For example, k is 4 means okay, the 1 is not equal to k. Number of 2. So second element, okay, it will be stored in the p plus 1. Okay, next memory location. Then j is become okay. What will happen? J is become 2 now. Okay, 2 not equal to 4. It will display number of to third element. Okay, it will stored in the p plus 2. Okay, 0 1 to second memory location. Okay, the j value is 2. Okay, and the element it will get stored. Then j will incremented. J is become 3. Then you will ask the user number 4 that is stored in the p plus 3. 0 first element is 0, second element is in 1, first memory location, the third element is second memory location, and fourth element is in the third memory location. J plus plus, then 4 equal to 4, it will come out of the loop, and j again is raised to 0. So the now entered number, we are displaying entered numbers. Okay, slash entered numbers are j not equal to k, j equal to 0, print of percentage d star p comma j. So p it is to finds the base address. J means p plus j 0 means it will display the number in the 0th memory location. Okay, 0th question. Okay, base address that will be displayed. Okay, then j is become a 1. The next element will be displayed. J is become 2. Then the second element. Third element will be displayed. J is 4. Fourth element will be displayed. Okay, star is a dereferencing operator. Base address plus 0 give you a star. The element in the base address uh, will be displayed because elements are stored in the consecutive memory location by when allocating using malloc. Then j is become 1, p plus 1, the next element will be displayed. Okay, then p plus 2, the third element will be displayed. P plus 3, fourth element will be displayed. Okay, then the loop will get halt. Okay, this example for the dynamic memory allocation, we will check the execution of the example. So malloc function. Okay, and open the zoom it. Used as a tool to use to zoom the screen. Okay, the same program which we discussed is shown here. This one here. Then we will run the program and check the output. So it asks how many numbers I enter 4. I'm entering number 1 1, number 2 10, number 3 100, number 4 1000. The program displays numbers are 1, 10, 100 and 1000. Okay. So here I am entering the number in this loop. I'm entering the number. Memory is allocated to the point variable p. Okay, I'm entering a number here, and as well as again the numbers are displayed here. Okay. Yes, the stored numbers are displayed here. Okay, that's it about the malloc function. Next, we are going to discuss about the cloc function. Cloc. This